Okay, let's take a look at some of the questions that you had from topic number 16, starting with number 9, the penny activities. You were asked to flip a penny into the air 50 times and keep track of how many heads and tails, and then use your sample results to construct a 95% confidence interval for the probability that a flipped penny lands heads. Okay, so to construct our confidence interval, first thing that we need to do is figure out what that standard error is. Now, in my case, I've gone ahead and run a simulation here of flipping the pennies and came up with a proportion here of 0.54. So for standard error, I've got to take that and then multiply by 1 minus p hat. So 1 minus 0.54, I hope, gives me 0.46, or I'm more tired than I thought. And then we have to divide by n. Well, in this case, it was 50 pennies. So if I plug in 0.54 times 0.46 divided by 50, now again, as you're doing this, you may very well need to put a set of parentheses around that product from your numerator, just to make it look better. So here's my standard error, and I'm going to go to 4 decimal places here and say that's approximately 0.0705. Okay, so that's computing the standard error. Now that I've got that number, I can do the actual confidence interval. Now again, our lovely formula here said that we were supposed to take p hat. All right, so in my case, that's the 0.54 plus or minus. Now here's, again, technical conditions here. They asked for a 95% confidence interval. So now we need to look up what our critical value, that z star, is. If it's 0.95, that critical value is always going to be 1.96. Okay, and then we have to multiply that by our newly calculated standard error, 0.0705. So again, you're looking for a confidence interval. We're looking for two different values, high end, low end. So type that in separately there. Again, whatever your value for p hat was, whatever your proportion turned out to be, 0.54 in my case, plus the 1.96, that z star critical value there, times my standard error turned out to be 0.0705. So that's going to give me the upper end of my interval. And then if I do the same thing, 0.54, but this time subtract 1.96 times my standard error, that's going to give me the low end. So I'm going to say that for flipping a penny, my confidence interval then is 0.678, say 2, if I'm going to be consistent with 4 decimal places. 0.6782, that's the high end, and then 4018 as my low end. Okay, so again, the idea here is that I am 95% confident that for this penny, if it's flipped a long time over and over again, the probability that it's going to end up heads will be somewhere between 0.4018 and 0.6782. Okay? All right, so you were supposed to do the same thing then for part B, but instead of flipping it, stand it up on its side, flick it with your finger, and spin it. Do this 50 times, and again, same process here. Take whatever proportion of heads, the p hat there, do the same thing. Find the standard error, multiply by, again, they're asking in all of these for a 95% confidence interval. So we're going to use that same critical value each time here of the 1.96. And then part C, consider balancing a penny on its side. Now, again, it's a good thing you guys got some free time on your hands. Um, Hopefully you're not tanking up on caffeinated drinks. My hand shakes too much. I can't get it to stand up. All right. Balance a penny on its side and then hit the table so that the penny falls over. Did it land on heads or tails? Do that 50 times. Okay. So now you've got a confidence interval for a flipped penny, a spun penny, and a tilted penny. Okay. Now, the authors went ahead and did theirs. Um, Sorry, just emphasizing again, they're asking for a 95% confidence interval, so that critical value is always going to be 1.96 every time they want a 95% confidence interval. So theirs turned out a little bit differently than mine. They came up with 0.52, so their confidence interval has slightly different numbers. And that's fine. I'm expecting to see that with your assignments, okay? So here's the confidence interval for the tossed or flipped coin. Here's their confidence interval if it's spun on its side. And here's their confidence interval if it's stood up and then it falls over. Okay? So your numbers, if you want to pause the video here, your numbers should be somewhat close to those. Okay? Now, again, that's all going to depend upon what you got for your proportions. And again, if yours are different from theirs, which I would expect a little bit anyway, that has a huge impact on your confidence interval. Okay, then they asked, part D, based on these results, which activities could plausibly be 50-50 for landing heads or tails? Well, again, depending upon your outcomes, you look now at your confidence interval in which ones contain zero point 0.5 in that interval. Well, again, for their answers, for part A, yes. So flipping a penny. Part B, the zero point 0.5 is definitely in that interval, yes. But notice there for part C, it's not. Okay. So then part E, they asked, what, which one of these appears to give you the highest probability of landing heads? It's that stand it on its side and then knock it over. Because you could, if you stop and think about it, if you're really, really trying to do this, if you're trying to skew the outcome, that's the one where you're going to have the most control over. Set that penny up so that the heads is facing the same side of the table and hit the same side of the table over and over again. Theoretically, if you get enough patience there, you could get 50 out of 50. Whereas flipping the coin or spinning it seems to be a little bit more random. Let's take a look at number 12 now. Organization called Nellie Mae, a branch of our federal monetary system here. Federal student loans. Extensive annual study of credit card usage by college students. Hopefully, that's going to be you guys soon. Back in 2004, they analyzed credit bureau data from a random sample of 1,413 undergraduate students, found that 76% of the students sampled held a credit card. So determine this margin of error with 95% confidence. Well, again, first thing we'll need to do is calculate what that standard error is. They're saying it's 76%. So again, we'll change that to a decimal, 0.76. And then we'll multiply it by its complement. So that should be 0.24. And our sample size here was a whopping 1413. So that gives us standard error here. Again, to 4 decimal places, I'm going to use 0.0114. So now for our confidence interval, again, from the survey, this is p hat 0.76 plus or minus, because they said 95% confidence interval. We're going to use that same critical value of 1.96 and multiply by the standard error, in this case 0.0114. Okay, so again, crunch those two numbers. Okay, so for part A, to answer their question, they wanted the margin of error. Now that, again, that's slightly different here. Well, I'm sorry, it is different from standard error. The margin of error, we're going to take exactly what I just showed you there for standard error. Okay, take the square root of this. But now for margin of error is when you're going to multiply that by that z star. So in this case, to answer their question, the margin of error, we'll round that off to 0.0222. Part B, then, they ask you to construct the confidence interval. So now it's just a matter of taking that value of the margin of error and adding and subtracting that to the p hat, 0.76 in this case. So that'll give us a confidence interval of 0.738 up to 0.782. Interpret that. We are 95% confident that somewhere between 73.8% and 78.2% of all undergraduate students between those ages have a credit card. Taking a survey in this case isn't going to give us the exact value, the exact proportion here for the population. We don't know that parameter. So you understand my use of that term is trying to be precise. We don't know the actual parameter. So a confidence interval here is estimating what that unknown value is. Okay, we're given a range of values and we're saying it's somewhere between these. Then, for part C, comment on whether or not the technical conditions required for the validity of this procedure are satisfied. Well, okay, technical condition number one, things have to be done randomly. Now, if we go back and read, boom, 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 they analyze credit bureau data from a random sample of students. Okay, so that's the first technical condition here. Then we've got to calculate whether the sample size was large enough. Okay, so we'll take the value of n. Okay, the sample size here was 1413. Multiply it by, yes, they do have a credit card. Yeah, that's way bigger than 10, so we're good on that. Now it's the smaller one where you've got to be careful. Same sample size, 1413, times the smaller proportion here. Again, those have to be complementary. They should have a sum of 1. The smaller one, well, okay, we're good in this case because that's 339.12, blah, blah, blah. And that also is bigger than 10. We need both of those products to be greater than 10, and we need some indication that it was a random sample. Okay, so that's what they're saying here for our central limit theorem with proportions. Those are what they call the technical conditions. All right, then people also had questions on number 14. I found this one fascinating because I watched The West Wing when it was on broadcast television. Um, and again, they took this huge chance of broadcasting an episode of the show live. Um, that wasn't done. Television started off, every broadcast was live, and then they realized, hey, we should probably practice this and record it and just play the recording. So it was unusual to broadcast, especially a drama like this. Um, so then they went ahead and treated this fictional presidential debate, this fictional race, um, as if it were real and conducted a poll. It was 1,208 people responded to the hold on. Hopefully, you got a little sense as you were reading this here. The poll was conducted online, and there were 1,208 people who responded. Okay. They screened the online respondents to try to ensure that they were representative of the population of adult Americans. So, although it was, you had to watch the show and then get online and complete our survey, they tried a few things to make sure that this was representative. Are the conditions met for the confidence interval procedure to be valid? Well, oops. The sample, again, if they were successful, we could say is representative. So for something like this, on a quiz or a test, that's exactly what I would expect you to read. The sample was conducted online and wasn't random, but the company made an effort to make the 1,208 responses representative. Okay, just acknowledge the fact that it wasn't a simple random sample. But in this case, maybe that's not a bad thing entirely. Okay. So again, the second part of it there was the sample size large enough. So again, you got to crunch the numbers here of sample size times the people voting for Jimmy Smith's. Yes, much bigger than 10. Sample size multiplied by Alan Alda. Yes, also bigger than 10. So we could say, yes, the conditions for validity here are met. Constructed then. So again, we got to go through the process there of calculating that standard error. They wanted 95% confidence, so it's that same Z star, 1.96. So there's our lovely confidence interval. For part C, based only on this confidence interval, do the sample data suggest that more than half of the population preferred Congressman Matt Santos? The answer to that would have to be yes, because again, look at this confidence interval here. Um, 0.5. is too low. So this suggests that more than half of the population favored Santos. Okay. Uh, I find as I commented on the notes there, if you go back and try and do a search here for this, it's just amazing. The actors were so good. Each of them, both Jimmy Smits and Alan Alda, stumbled over their words, at least in this one clip, but they kept going. They stayed in character because both of them are terrific actors. They stayed in character and they just kept on going. I found that really impressive because, again, it was a live broadcast. Normally, these actors will be, doing this on videotape. It's going to be recorded, and oh, I screwed up. Director calls cut, and then we try it again. We do another take. But they knew it was live, and they've done enough acting on stage. All right, you mess up, it's okay. You just keep going, and you're a professional. So yeah, might be interesting, might be amusing to go back and watch some of those. All right, I hope this helps, and then we'll move on from here.